All right, welcome back. So in the previous video, we saw an overview of what our data set is and what it contains, right? So in this specific video, we're going to see we're going to do some of the actions or tasks that we are required to do over here. All right, so let's get started straight away. So we've loaded our data set, right? And then we've seen the first 5 records over here. So we can see, if we pick specifically say children, right? If we pick children, we can actually see the unique number of children that these customers are having. So if we use the unique function over here, right? If we use the unique function over here, you can see that we have customers who are having no child. There are some who are having only one child. There are some who are having say 3 children. There are some who are having 2 children, some with 5, some with 4. Okay, so these are the children that they have. These are their dependencies, and these are going to affect the charges that they will the insurance company need to pay to these customers. So they also need to take this into consideration. Now let's see the number of rows and the number of columns that we have in our data set. So in this case, in that specific scenario, we're going to use what is called ship, right? So as you can see over here, if we do data.ship, right, we can see that we have 1,338, right, rows with 7 columns, right? So that's what you have. So if you go above over here, right, we have 1, 2, 3, 4, 5, 6, 7, right? So that's seven columns, right? And then we have 1,138, right? Don't forget that this one will give you only the first 5 rows, right? Only the first 5 rows, right? But we have over 1,000 rows in there, right? We have over 1,000 rows in there. Okay, so this is just using the head. It's just a summary, right? Just a summary of it. Now, having seen what we have, this is the data that we have. So we can check the various types. For instance, if you see the age, right, we can see that the age column is an integer type, right? We can see that the sex column is a categorical type, and then the BMI is formed for decimal. So we can say that is a float, right? The children is categorical, right? Smoker, right? Smoker. Now, what is smoker? Because if this is categorical, what do you think smoker will be? It's also categorical. It's either yes or no. Okay. Region, of course, is also supposed to be categorical, and then charge is supposed to be float. So let's see. Without doing this manually, we can just use D types, right? You can use D types to do that. Now over here, you can see what we have over here, right? We have age, right? We have age to be int. That's what we have here. Now sex is supposed to be categorical. Now over here you see that we have sex to be objects, right? Because sex we have we see that male or female, right? So ideally you're supposed to have this as a categorical data, right? So if you're going to build a machine learning algorithm on this, then you need to deal with this, right? You need to actually deal with this. So it might happen that there's something else in the column that you need to actually figure that one out. Okay, we will see this in action as we progress in the course. When we get to the machine learning part where we are building the various machine learning algorithms, right? For instance, we're going to build something like this, right? We're going to build something like this where you actually be predicting the Zomato, right? So if for instance a restaurant want to see how well they are doing, or they want to see their ratings, right? So then they can actually see it from here, right? They can just do it. So this is a machine learning algorithm which is running behind that. Now I can predict the rating of a restaurant, right? If a restaurant is having these attributes, I can predict that. Okay, now you see that we have a rating of 4.1 over there. Okay, so we actually going to do that as we progress in the course. So if you have such things, right? So that's why we say that 70% or 80% of your time you're going to spend in cleaning your data. Okay, so this is actually the sex, which is male, right? Which is either male or female, supposed to be categorical, but in this case we have it to be objects. So if we are going to build algorithm, we need to deal with that. BMI, of course, is a float. That makes sense, right? If you see the BMI column, right? The BMI over here, yeah, it's a float. You see that in the form of a decimal, so it's a float. The same thing with charges. Charges supposed to give us float, right? So that's cool. And then if you see say children is supposed to be categorical as well, right? But you see that children is int, right? So in this case, it's going to rank it, right? So it's going to say that if you build an algorithm on this algorithm, is going to see this one as a ranking numbers, right? Because it's going to, what it's going to do is that it's going to say that, okay, family with 3 children are greater than family with one child, or family with say one child is greater than family with no child, which we don't want to make such an assumption. I mean, it doesn't even make sense that one family is greater than another family. It doesn't, with regards to the number of children, it doesn't actually make any sense in that case. So we need to also correct that, right? If we are going to build a machine learning algorithm on that. Now, these are the data. I mean, the data types. So what I want to show you is that you can see the data type just using this D types, right? You can see that. Now we can also see if some of the data points were present or they were missing, right? We can check that using the checking the missing values, right? So over here, what we're going to use is using this function is null, right? So if we do that, we're going to come up with some true or false, right? A lot of true or false in there, right? A lot of true or false in there. Going to go through all the 1,338 rows and the 7 columns, right? And then see if there are null values in there, right? If there are null values in there, then it will return true, right? If there are null values in there, if it encounters any null value, remember that when we are talking about null values, right? It's, I mean, Panda sees null values as NaN, right? So that is not a number. So if anytime it encounters that, it will return true. However, if it doesn't encounter that and there's a value there, then it will return false. Okay, so you can see that there's a lot of false in here, right? There are a lot of false in here. However, if they are true in here, we cannot actually figure it out because this is, I mean, even this data is just 1,338. What if it is about 2,000, 20,000, 30,000? I mean, it's going to be very difficult for you to figure it out. Besides, when you see this part, right, it breaks somewhere. I mean, from say 29, then it will break, it will go all the way to 1,308, right? So whatever is in between here, we cannot even figure it out. Okay, so I mean, just using this data is now is actually not quite effective, right? So other thing that we can do is to do this, right? We can actually do this. This is just the same thing as that. I'm just storing the values in the new variable called now, and then I'll go and loop through this, right? I'm going to loop through this one. Now, this is what I'm going to go through and then do, right? Let me show you the output of what is going to come. Okay, so what I'm going to do is that I'll go through all the columns, right? Let me change this. I'm going to go through all these columns, right? So for instance, if we take the age, right, I'll go through the age column and then see if there are any null values in there. I'll say that, yeah, there's null values in there. So that's what I'm doing for I in null, right? So remember that I store everything, all these, right? Everything that you see over here is stored in this null. So that's why I do null.head and you can see what I have, right? So if any item, right, for instance, false, right, if I see false here, right, I'll compare false with true, right? So if false, right, if false is equivalent to true, right, then I'll say that then I'll print this message. Otherwise, since over here false is not equal to true, I'll print this. That's why you see there are no null values in there, so it's printing the second statement, right? So anytime it encounters true, is equivalent to true, right? Which in this case is valid, right? So then it will print the first one for me. There are null values in there, right? In our case, we don't have null values in there, right? We don't have null values in there. So you can see that we've been able to loop through all the, let me see how many columns. We have 7, right? So we've been able to loop through all the 7 columns, right? So we have 1, 2, 3, 4, 5, 6, 7. So we've been able to loop through all of them, right? So you see we have 1, 2, 3, 4, 5, 6, 7, right? So it will go through this and see if there are any true in there. It will go through that, all the columns and see if there are any true in there. If it doesn't find any of them, for instance, if we go through the age column, it doesn't find any true, it will print that. If it goes through this, if it doesn't find any true, it will print that. If it goes through this, if it doesn't find any true, it will print that, right? However, if it encounters any true, then it will print that there are null values in there. In our case, we don't have any null values in there. Later on, we will see some of the data set that we'll be dealing with that are having a lot of null values, right? For instance, the one that we are going to use to build this is even having a lot of them. We see how we're going to actually deal with that. All right. Now, the next thing that we can do, which is quite efficient, right, is just do this. Is just do this without doing all this null, right? I mean, without doing this, without doing that, right? Without doing all this, right? The alternative, I mean, the best alternative that you can do is just do this. Okay, just do this. Now, if I do that, you see what I have. So this one will go through all the column just like we're doing manually over here. It will do the same thing, and then count if it encounters any true. If it encounters any true, it will count the true. So for instance, if it goes into the age column, it will try to find the true. If there's any true in there, it will count it true. For instance, if it encounters say 15 true, it will bring out true over here. It will count everything and then sum them, right? And sum them and then bring it to you. If the encounter say if it goes through say children and then find some null values in there, right? That is data that is not present, right? It will just count them. So maybe it encounters say 7 of them, right? Then it will just count all of them, right? 1 2 3 4 5 6 7. Then it will bring you 7 that it encounters 7 null values in there. Okay, in our case they were all false, right? They were all false, meaning that there were no null values in there. That's why we did not encounter any true in there. That's why you can see 0 0 in there. Okay, so this is quite efficient, and it's advisable to actually use that. Okay, now let's see the 5 number summary, right? So we've talked about the 5 number summary. Let me actually do this. Okay, we've talked about the 5 number summary in our previous classes, right? Where we have the box plots like that, right? Where we have the minimum over here, then we have the Q1, we have the median, right? Which is also the same as the Q2, we have the Q3, and then the maximum, right? We have the maximum over here. Okay, so these are the 5 number summary that we're going to trying to get over here. Okay, so what we're going to actually do, right? Let me show you this before the output. Okay, let me open this one up, then try to squeeze it a bit. Okay, so what we're doing over here is this. So we have we have this package called percentile, right? Called percentile. So we're going to use that to calculate the quartiles, right? So you can see over here, I'm creating a new data over here, right? So in my data, I'm going to locate all the rows, right? And then some of the columns that I'm interested in, right? Which is the age, the BMI, and then the children and charges, right? I'm going to take that, right? Which is the columns that are containing in integer and float, right? The columns that are containing integer and then float, right? That's because we cannot calculate the percentiles or the quartiles on the object data types or on the string data type. So or the character data type. So what we're going to select is the columns or the features that are containing int or float, right? That's what we're going to actually select over here. So we select all the rows, right, and then some of the columns that we're interested in. Then we use the percentile function to calculate the various quartiles. Okay, so I pass in my new data, which is the new data that I'm interested in that I've selected over here, right? I pass in that, so you can see that 25th is nothing but if I draw the box plot for you to see, right? So the 25th is nothing but the Q1, right? So the Q1 is the same as the 25th percentile or the 25th quartile, if you want to consider it that way, and then the Q2 is nothing but the 50th, right? That is where the 50% of the data is at either side of the box plot, right? And then we have the Q3, which is nothing but the 75th percentile, right? And then we have the maximum over here, right? The minimum and then the maximum. Okay, that's why you see 25 here standing for the Q1. You see 50 here standing for the Q2, right? Standing for the Q2, which is the 50th percentile. And then you have the Q3. Right, we have the Q3, which is 75, that you can see over here. Okay, so now that is done. If we do that, we're actually going to get this Q1, Q2, and then the Q3, right? So that's why when we're dealing with this in the start class, I told you that when we get to the lab session, we're not actually going to calculate this by hand, but we have some functions in Python that will actually help us to do this. Now that is done. What we're going to do is to find the minimum and then the maximum. Okay, so we're going to use new data.min, which will give you the minimum, and then new data.max, which is you can do this in a separate line, right? You can do this, maybe you want the minimum, right? So you can do maybe minimum equals we have our data in new data, right? New data. Okay, then you use dot mean, right? So in this case, you see that we just use the dot mean function. This one is going to give you the minimum, right? So you can also find the maximum by just doing the same thing here, right? So instead of dot mean, in this case, you do dot max. Okay, so you can do this single line in 2 lines of code. If you want to separate it and then see it better, you can do it like this. Okay, and then so now we can print the 5 number summary. So this one here is going to contain the queues, right? That is the Q1s, the Q2, and the Q3s, and then this one is going to contain the minimum and then the maximum, right? So this will contain the minimum and then the maximum. Then this one will contain the queues, right? That's the Q1 and the Q3. Then we have our 5 number summary, right? So what we're going to do is to first to print this, the minimum and then the maximum. So that's what you're doing here. We printed the minimum, then we bring this /n to so that the next one will be printed on the next line, right? So our data underscore mean is the one that contains the minimum, right? And then we print the Q1, right? The Q1, which is the first quartile. So we print that one too. That's why you can actually see it over here. Then we print, so this one is actually printing the line, the dash line that you can see here, right? That's print, then dash multiply by 10. So we just duplicate it. Whatever we have here, we duplicate it. That's why you have this line here, just to separate what we're printing. Okay, so we have the minimum for each of them: minimum for age, minimum for BMI, minimum for children, charges. So you can see that we have minimum for age is 18. We have 18 years to be the minimum of the customers that will come for that have subscribed for the insurance, right? And then we have the minimum children, of course, to be the family which is not having no child, or maybe the person who's not having no child, right? It could be, the person who is 18 years or something like that. And then we have the minimum charges, right? That is 1,102, okay, 0.87335, okay. So that is it. That's what we have for the minimum, right? Minimum for each of them, of the attribute that we selected. And then we can see that we have the Q1, we have the Q1, we have the median, we have the Q3, right? So the Q1 for each of them. So for age, for BMI, for children, okay. And then we have for median, we have median too. Then we have Q3 as well, okay. Now you can see the maximum that we have, the maximum for each of them, right? You can see the maximum. So the maximum age is 64 years, right? So for those who subscribe for the loan, the maximum age is 64. We have BMI to be 53.13, and then we have the number of children. The maximum children that the family who have subscribed for the insurance is having is 5. Okay, so this is quite an interesting information that we can get from this analysis over here. Okay. Now, what we can do is to actually also use the describe function over here, right? So if we use the describe function, instead of doing this manually, so what we did this manually, right? Just like we're doing this, finding the null values manually. What we can do is to actually use the describe function, okay? We can use the describe function to actually see, to do the same thing over here. So if you can see over here, we have, let me actually do this. Okay, so now you see that we have standard deviation. We have the count of them. We have 1,338, right? So this is going to be consistent for all of them, because that's the record that we have. Remember that we check the shape of our data. That is the number of rows and columns that we have. So this is common for all of them. What is different here is the mean, right? So if you check the mean for the age, right? So on average, we have 39 years old, right? The customers that will come for the insurance also have subscribed for the insurance of the company. It's on average, it's 39. It's 39 years of age, right? And then if you check the BMI of these customers, right? On average, we have 30, right? And then the children, on average, each family is having a child. Right, and then the charges, remember that we're talking of average, so there might be some family or some customers who are not having children, but we're talking of average here. Okay, so on average, this the charges that we have, that is the hospital charges, right, of these customers is around 13,270 over here. Okay, so I mean, if customers are subscribing for an insurance, then the insurance will have a better overview of on average what they expect to pay or spend on each of these customers, right? So on average, they should expect to spend 13,270, right? And this is something they need to factor into the charges that they need to charge their customers. All right, now we have what is called the standard deviation. We have the minimum, the 25th. So now you see that our Q1 is here, our Q2 is here, our Q3 here, our maximum is here. So you see that we still have the 5-number summary here. If we use just the describe without doing it manually like we did earlier on by hand, right? We don't need to do that. We are going to use describe as we progress in this course. Okay, and describe will actually give you the same thing. So remember, if for instance the maximum for each of these columns, we did maximum for each of these columns. If we use just the describe, you still have the maximum for each of the columns. Okay, you still have the same thing. So you see that you have 64 here, the same thing that you have it here. You see that 53, 53.1 something something. You see that you have the same thing, 5.0. You see that you have it, right, 63,770. You see that you have the same thing. So you can use just the describe to achieve the same thing by just using hand to achieve it. You can use the describe function to achieve the same thing. Okay, so I mean, moving on, that's what we're going to use. All right, so in the next video, what we're going to consider is the distribution of the various attributes, right? The distribution of the various attributes is what we're going to consider in this video. So see you in the next video.